Hello everyone, welcome to the course on artificial intelligence and in industrial and management engineering. The course is being taught by Professor Deepu Philip and myself, that is Dr. Prabal. Till now in the course, we have covered the foundations of learning, then what is machine learning. Also, we have covered different things like what are the different kinds of machine learning. So, now we will try to cover what is the complete roadmap for conducting an end-to-end machine learning mini project, right? Also, we will try to cover the semi-supervised learning that we have left in the previous lecture. So, let's continue from there. So, the agenda for today is first we will try to complete supervised machine learning. Then we will discuss about the complete process of conducting a machine learning project step by step. After that, we will introduce a diamonds dataset, which is a classical example for conducting a machine learning project. Then we will understand what are the different kinds of terminologies that we need to understand for doing machine learning. Okay. After that, we will dive deeper into the machine learning roadmap, and finally, we will try to understand how to conduct a linear regression supervised learning process by using diamonds dataset, and we will also cover this step by coding it live in the Jupyter lab. Okay. So let's start with the semi-supervised learning. So we have already covered what is a supervised machine learning and what is unsupervised machine learning. So this is somewhere in between. So the core idea for this kind of machine learning is we use a small labeled data and a large amount of unlabeled data. So there are various applications for these kinds of data sets, like our photo organizations app, right? So we have large amount of photos in our applications, but the photo organization app asks you for only few faces to identify, right? After that, it identifies everything. So this is an example of these kind of machine learning problems where we use a small labeled data and a large amount of unlabeled data. After that, we leverage both supervised and unsupervised ML techniques. So when to use this? You can use when labeled data is expensive or time consuming. So for example, medical image diagnosis. Second, you can use when unlabeled data is abundant or easy to collect. So as an example, we can think about a company that captures reviews online, right? So we can capture a large amount of reviews online, but the manually labeled reviews will be less. So in these kinds of scenarios, we can use semi-supervised learning. Now let's talk about how broad steps of how we conduct semi-supervised learning. So steps. First, train the model on a small label data. So this is a supervised learning step, right? After that, make predictions using trained model and make predictions on unlabeled data. So now in these two steps we have some predictions on the unlabeled data. So we have received our response variables for some of the rows, right? Now the third step is use the model's most reliable predictions as pseudo labels. So the problem of this large amount of unlabeled data gets reduced by utilizing and creating these pseudo labels, right? Now in the last step we retrain the model on this large augmented data set. Okay, and usually this is a repeatable process, so we can repeat this stage. So as an example, I have just told you photo organization apps like Google Photos, they take few labeled data and has large unlabeled face data, and once they ask their users to recognize few of them, the system automatically recognizes similar faces, right? So this is a complete broad overview of what is semi-supervised learning. Okay, now let us talk about the flowchart of the complete machine learning process. Okay, so we have a data set and we try to do some type of learning process, as we have learned in the earlier classes, to perform analysis of different kinds. So we first need to acquire data, right? So the first step is to data acquisition. Okay, the next step is data pre-processing. Data acquisition can be performed in different ways, like let's say you have a client that wants to gain insights in their own data. So the client approaches you, gives their own data to you, and then the data acquisition process is very easy for you in that kind of conditions. But sometimes, like some researchers try to identify insights from let's say social media, so they try to acquire this data set using different kinds of APIs, or they try to scrape these kinds of data from, say, like the social media app like X or other small blogging platforms. So these kinds of data are very useful, but the data acquisition process changes with every kind of problem. The next step is to conduct data pre-processing. So in this, let's say you have acquired your data set, but you are finding that some kinds of fields are not available in that data set. So if you have 1, 2, 3, 10 columns in a particular data set, and some of the values for different columns for a particular row is absent, then what you have to do is you need to first clean the data. So cleaning is broadly known as data pre-processing or data wrangling. So in this step you perform pre-processing steps like missing data, or feature selection. So we may identify at this step that what are the important features that we need to utilize for our further processing. Finally, we will get a finalized data set. Now we start our machine learning process. So the first step is to divide this data set into a training data set and a test data set. Okay. This step is very important, and usually people do this in 80% 20% fashion. So 80% is training data set and 20% is test data set, okay, or 70-30 like that. But what is the main reason of doing this? So let's say you are training a machine learning algorithm on your complete training data set and it has beautifully trained for your data, but as your data set updates and you want to predict what will be the value of the target or response for the newly found input data features, your training algorithm may fail. Why? Because you have shown all your input data to the training algorithm, but your algorithm might not have seen the new data that is very different from what you have used to train your data, right? So that is why we first segregate our data into training data set and test data set. Now whatever we do, we first perform all our operations on our training data set. So the next step is feature processing. So here we may utilize different features and try to make new features out of those by utilizing different kinds of operations, mathematical operations on those features that the developer or the machine learning engineer is considering valuable. After these operations, the features that we are getting may be more useful to the complete machine learning model. So all those different steps that we perform are inside this window of feature processing. Finally, we apply our machine learning algorithm. And this will give us a model. Now whatever we have created as a model, we need to evaluate it as well. So after model creation, we need to test it, right? So we utilize this model and perform all our predictions using this test data set, okay, and the response variable that we get and the actual values of the response variables which we do have from the early stages, we try to compare them and utilize various matrices like mean absolute error, mean squared error. These kind of matrices will help us evaluate how good our model has been trained on the data set, okay. So this is the complete flowchart of the machine learning process. Now let us get introduced to what is diamond dataset and what are the different features that are contained in it, okay. So we are using this diamonds dataset which has around 53,940 rows and 10 columns, okay. So the problem is that the pricing of diamonds is very complex, okay. So we are trying to conduct a machine learning study where we can easily predict the values of a particular diamond utilizing those features that we have captured in this data set. So the target variable is price of the diamond, that is in dollars, okay. And the features that are available in this data set is carat, quality, cut of the diamond, color of the diamond, its dimensions like x, y, z, the depth of the diamond and the table, okay. So diamonds are graded based on these qualities like carat, quality, cut, colors. Now out of these we have already introduced what are the different data types. So out of these features, the cut of the diamond, color and clarity, these are categorical features. Okay. Then price is in dollars and the range is 326 to 18,823. So the most expensive diamond cost this much in this data set. The carat represents the weight of the diamond and this has a distribution from 0.2 to 5.01. Okay. The next is the cut of the diamond, which is the what is the quality of the cut. So it can be fair, good, very good, premium or ideal. Another is the color of the diamond and it is represented by letters like J, which is worst color, to D, which is best color. So clarity, this is a measurement of how clear the diamond is. So it can go from I1, which is worst, or S12, SI2, SI1, VS2, VS1, VVS2, VVS1 and IF, which is the best clarity. Okay. So you might be thinking why we are expanding our data set in this fashion. So whenever you try to conduct any kind of machine learning study, you first need to have a brief domain knowledge. So if your client is giving you a data set on diamond, then you must know what are the different aspects of a diamond that needs to be understood before conducting any kind of study. So this is why we are trying to expand on each characteristics of the diamond. Now other features that are available in this data set is X, which is the length. This is given in mm and it ranges from 0 to 10.74. Now 0 length diamond will not cost anything. So if there is some 0 values in the data set, it might be possible that they don't have any values for that. So they pre-filled it with 0. So we will try to remove these kinds of outliers as well from our data set when we perform our study. Okay. Y is the width. This is also in mm and it ranges from 0 to 58.9 mm. Finally, Z is depth in mm and it ranges from 0 to 31.8. Now another feature with the name depth is also given to you in the data set, which is the total depth percentage. So this gets calculated using this formula, that is Z divided by mean of x comma y. Okay. and this ranges from 43 to 79. So when I say it ranges from this to this, it means that whatever data you will find in the column of depth, it has minimum value of 43 and maximum of 79. Finally, the table column in the data set is the width of top of diamond relative to the widest point, and it is ranging from 43 to 95. So now let's start understanding the general terminology of machine learning. So here I have already introduced few of these terms, like training is fitting a model on the data to estimate parameters, rows. These are observations in the data set. Columns, these are usually called X or features of the data set. Target, this is usually called Y or response or target feature of the data set. Finally, the loss function. So it quantifies the deviation between your predicted output of the model and the actual target variable. So if we think about our diamonds data set, so rows are 53,940 rows. We have 10 columns, okay, and the target is the price of the diamond that we need to predict, price of the diamond, right? And a loss function will try to quantify the deviations between predicted output and the actual target variable. So as I have already said that there will be a training data set and test data set. So your test data set will have your price of the diamond available, the actual target variable, that is the actual price of the diamond. So when you, let's say you are just differentiating between actual price of the diamond minus predicted price. So this will be a simple loss function which will tell you what is the deviation from your actual price to the predicted price, okay. So that is how your machine learning model will be communicated to different peoples in the same domain. Thank you.